In this video, we'll look at solving a trigonometric word problem using substitution. The equation given is h at t equals -4 sine of pi over 4 t minus 1 plus 2.5. This is from a word problem in your textbook, page 428, number 12. And it asks, where is it below the water, below 0, for the first 24 seconds? Okay, well the first thing we're going to do is substitute for all these things inside the sign here. That is, we're going to let a equal pi over 4 t minus 1. And that's nice because then we have h at t equals -4 sine of a plus 2.5. And now the equation is going to be a lot easier to work with. And since we're looking where is it below the water, we'll set the water equal to 0. The height of the water limit is 0. And then we're going to work on that. So we have 0 equals -4 sine of a plus 2.5. Let's subtract 2.5 both sides. And we get -2.5 equals -4 sine a. And divide both sides by -4. And we get sine a. You can leave it as a fraction. I'm just going to change it to 0.6. So we have sine a is 0.6. Oh, wait, I think I did that math wrong. I'm going to check using my calculator. No shame in using your calculator. 2.5 divided by 4. Yeah, 0.625. So sine a equals 0.625. Okay, when you see something like this, it's time to sketch raw solve. Let's sketch first. We'll make a x and y axis. Make sure to label your arrows and label your x and y axis. And the sketch is, where is sine positive? Well, put my initial arm clearly visible here. And sine's positive in quadrant 1 and in quadrant 2. We'll call this rotation A1, call this rotation A2, and we'll label the related acute angles beta, or B. And then we'll solve for those related acute angles. That is, sketch this thing, done, and now solve the related acute angle. So sketch raw, so sine of, now we're looking for beta, the angle inside this triangle. We change this fraction or this number to positive. It already was, but if it had been negative, we'd change it. And then how do you solve for beta when it's sine of beta? Take the inverse of sine, and you get that beta is, we're going to be rounding here. Make sure your calculator's in radians, minus inverse sine of 0.625, and you get approximately 0.675. Don't worry that those numbers look similar, it's coincidence, just the way the numeracy works out. We've got a related acute angle of 0.675. Okay, sketched it, found the related acute angle, now solve for the a's. A1 is in quadrant 1, so it's just the same number, 0.675. A2 is in quadrant 2, you calculate that by doing pi take away 0.675. That's always the formula for quadrant 2. We'll need a rounding dot because we're going to round based on pi minus 0.675, and we get 2.4, we're going to round to 3 decimal places, 2.467. Okay, we've solved, sketched raw solved for the a values, but remember a wasn't a, it was originally, we substituted for it, so we're going to substitute back. Pi over 4 t, we'll call this t1, minus 1 equals 0.675. I'll put a line here. And I want to get t1 by itself. How do I do that? Divide both sides by pi over 4. And I'll get t1 minus 1 equals, what? 0.675 divided by brackets pi over 4. And I get 0. Let's put a rounding dot again because I'm going to round to 3 decimals, 859. And now add 1 to both sides, and I get t1 is 1.859. Same thing on the other side. This a2 is really pi over 4, we'll call it t2, minus 1. equals 2.467. Once again, we'll divide both sides by pi over 4. And we'll get t2 minus 1 is, what's 2.467 divided by pi over 4. Need to put brackets there. And I get 3.141 approximately. So add 1 to both sides, and t2 is 4.141. We've got our first 2 times, but the period has changed here. There's going to be a whole bunch of t's in the first 24 seconds. So let's calculate the period. Period, it's a sine wave. The period of sine is normally 2 pi, but in this case it's 2 pi divided by the k value, which is pi over 4, which is the same as 2 pi times, when you're dividing by a fraction, times by its flip. And 2 pi times 4 is 8 pi, divided by pi gives 8. So the period is 8 seconds. That's going to make it easy to calculate t3. t3 is just 1.859, the previous answer, plus the 8 seconds. That gives a t3 of 9.859. And same thing with t4, I'll put a little line here. t4 is based on where did the last answer occur. Add the period to get the next one. And you get t4 is 12.141. Let's do the same thing with t5. t5 is the last answer, 9.859, plus 8. You can see why I'm making pairs here, right? They're just 2 points that keep reoccurring every cycle of the wave. t5 is 9.859 plus 8, which is 17.859. And you can use your calculator if you want. And the t6 is the last answer, 12.141 plus 8, which of course is 20.141. You might think to keep going, except I know we're done because the next one you can check on your calculator if you want. 17.859 plus 8 gives 25.859, which of course is beyond the questions, when is it below 0 for the first 24 seconds. Okay, we've got all these answers. We've got all these times it's exactly at the water. But one question remains. Which ones is it below the water between? As in, obviously it goes below the water, comes up, goes below, comes up, but does it go below before T1 or between T1 and T2? Is it below the water between T3 and T4 or between T4 and T5? So we're going to need a quick sketch to kind of see what's happening here and be able to figure out where it first goes below the water. And here's how I'm going to do my sketch. I could spend a lot of time graphing it, but instead I look at the transformations here and see, okay, it's been compressed by this number and it's been shifted to the right 1. So here at 1, sine wave's supposed to start in the middle. That is, in the middle, just think about a regular sine wave. It starts in the middle and goes up. But this sine wave, here's its starting point at plus 2.5 at time equals 1 because it's been shifted right 1. But instead of going up right away, this particular sine wave has been reflected in the x-axis. And so what that means is starting at 1, it's going down. And we know the first place it hits is at 1.859. That's right here. Now I know it goes down from 1.859 and comes up at the next spot. Let's call that T2. And then a wave has to keep moving, of course, in a wave-like fashion. So then it's going to go down between T3. I had to erase the x-axis there to make space. I'll put it back. And here's T3 and T4. And so what I did there with a quick sketch is I don't know just where the zeros are anymore. I know exactly where it's below and where it's above. And the question is asking me where it's below 0. It's going to be below 0 between T1 and T2 and between T3 and T4. And if you keep going, I put an arrow here to show it keeps going. And between T5 and T6. Now I can say my final answer. Therefore, it is below 0 for, and now I'm going to state all the intervals. It's below 0 from 1.859 is less than t, which is less than 4.141, can't equal that because then it's exactly at 0, and it doesn't say at or below, it just says below, so no equal signs. And it's also below, again, from 9.859 is less than t, which is less than 12.141. And finally, in the first 24 seconds anyway, between 17.859 is less than t, is less than 20.141. And we've done it. We solved the trigonometric word problem using substitution. We substituted in the beginning, we isolated for sine A, we sketched, found the related acute angle, and solved, but then we substituted back in, found each t, and the corresponding subsequent t's using the period. And then finally we had to make a quick sketch of the actual sine wave to see which t's it's between that it's under versus which t's it's above 0, and we found our final intervals.